Hello, class. Today we're recording another video as we come back from a break. First video after coming back from break, we're going to be moving on to lesson 18, which is going to be a review about least common multiples and greatest common factors. These are things that kids really often sort of get confused with each other. So we just kind of want to once again go over it, review what they are to make sure that we can find them if we are asked about it. In our opening here, it tells us specifically what both of these are. Our greatest common factor of two whole numbers, can't both be zero, is the greatest whole number that is a factor of each of these two different numbers. Greatest common factor of two whole numbers is A and B is denoted by GCF AB. So if I were to look down here, for example 1, we're finding the greatest common factor. Since we're finding it between 12 and 18, it's noted as GCF 12, 18. First number is A, second number is B. The least common multiple of two numbers is something completely different. It's the smallest whole number, greater than 0, that is a multiple of both numbers. So we need to talk about what a factor is and what a multiple is. A factor is when we take our number and we break it into chunks that multiply into that number. Multiples is when we take that number and continue to multiply it by 1, by 2, by 3, by 4. So what we're going to do is we're going to work on example 1 just to show sort of an example of how to find greatest common factor. And then we're going to work together on example 2 to find our least common multiple. We're going to work on those two, and then I'll show you guys what you guys are going to need to do for classwork on your own independently. So first up, let's look at greatest common factor. We're going to be finding the greatest common factor of 12 and 18, just like we had already talked about. Listing factor pairs in order to help ensures that we don't miss any common factors. We're going to be starting with 1 multiplied by the number. So since we're starting out with 12, I'm going to start out with 1 times the number itself, 12. That's easy. That's something that everything has. Every single number has a factor that is 1 and the factor that is itself. There is not a single number that does not have that. So let's continue on. Is 2 a factor of 12? Can I divide 12 by 2 evenly? Yes. Yes, I can. If I divide both sides by 2, both sides. If I divide 12 by 2, I get 6. So that means that 2 and 6 are both going to be factors of 12. Let's go on to the next number. Is 3 a factor of 12? Well, yes. I can divide 12 by 3 evenly. And if I divide 12 by 3, if I do 12 divided by 3, I am going to get 4. And then from here, we would continue, but the next number is 4, and, 4 is already on our list. So once we come across a number that's already on our list, that kind of just signals a stopping point, because then anything that if I continue going up, I'm just going to run into numbers that I've already run into. So let's do the same with 18. 18, obviously, we can have 1 and 18. that's going to be, no matter what, that is going to be on our greatest common factor list. It might not be the greatest common factor, but it is at least going to be on our list of factors. Let's check 2. Can I divide 18 evenly by 2? Yes. Yes, I can. If I divide 18 by 2, I am going to get 9. Okay, so there's some more factors. What about 3? Can I divide 18 evenly by 3? Good news. I can. If I divide 18 by 3, if I were to do 18 divided by 3, what am I going to get? I'm going to get 6. So then 6 goes over here. Now, they kind of gave it away by only giving us 3 boxes here. But what I want to do is I kind of want to keep going just to make sure that they didn't mess up by only giving us 3 boxes here. Can 18 be evenly divided by 4? No, that's going to give us a decimal or a fraction at the end of our division, meaning it's not a factor. Same with 5. 18 can't be divided evenly by 5. And then when I get to 6, well, 6 is already on my list. So there's no reason to keep going forward. Because if I keep going forward, I just continue to run into numbers that I've already run into. So what we're going to do here is, well, I've listed out all of my factor pairs. So now what I can do is move to the next step. Circle all factors that appear on both lists. I'm going to do this in a different color. So let's circle everything that's on both lists. Well, obviously 1 is going to be on both lists because 1 is on every list. 2 is on both lists. 3 is on both lists. 4, well, 4 is only on our top list. 5 isn't on any of the lists. But 6 is on both lists. And if I keep going up, the next number that I come across is 9, but that's only on one of the lists. Then 12, but that's only on one of the lists. And then 18, that's only on one of the lists. So there we go. I've circled all of the factors that have appeared on both lists. Well, now what do? I found all of my common factors. If this question was just asking me, hey, find all of your common factors, we'd be done. But as we know, this isn't asking for the common factors. It's asking for the greatest common factor. So I need to find out which of these factors is the greatest. Lucky for us, that's pretty easy. All we have to do is find out which number is the biggest number out of all of these. Which number is the biggest? 1, 2, 3, or 6? I'm pausing for dramatic effect, but hopefully it shouldn't be too difficult for you to realize 6 is going to be the greatest number, and it asks us to put a triangle around the greatest of these common factors. So what we've put a triangle around is 6, which means that 6 is our greatest common factor. I'm going to put it right up there, right next to our GCF, to let us know that that's going to be 6. So our greatest common factor between 12 and 18 is going to be 6. Let's do one more example. Let's go all the way down to here to the exercise, and let's do 30 and 50. So let's list out, I'm going to list out in blue all of my factors of the number 30. Okay, so obviously 1 and 30. Can I divide them both by 2? Yes, I can divide 30 by 2. If I divide 30 by 2, I get 15. So 2 and 15 need to be factors. What about 3? Let's go to the next number, 3. I can divide 30 by 3. If I divide 30 by 3, I get 10. So that means that 3 and 10 both need to be factors of 30. If I go down to 4, well, 30 can't be divided evenly by 4, so 4 isn't a factor. Well, let's go down one more. Let's go to 5. 5, I can divide 30 by 5. If I divide 30 by 5, I'm going to get 6. So that means that 5 and 6 need to be factors. Okay, if I keep going, oh, well, the next number is 6. And I already have 6 on my other side, so I can stop there. These are all of my factors of 30 listed out right there. There's 8 of them. Let's check with 50. I'm going to do my factors of 50. I'm going to do those in red. Once again, same as before, always start out with 1 and your number. So 1 and 50. Those are factors. No, let's check the next one. 2. I can divide 50 by 2. If I divide 50 by 2, I get 25. So that means that 2 and 25 need to be factors. Let's check the next number. 3. I can't divide 50 evenly by 3. Skip it. 4. I can't divide 50 evenly by 4. Skip it. Let's head to 5. 5. I could divide 50 by 5 easily. If I divide 50 by 5, I'm going to get 10. So that means that 5 and 10 both need to be factors of 50. Well, let's keep going. Next is 6. Can't divide 50 by 6. Can't divide 50 by 7 evenly. Can't divide it by 8 evenly. I can't divide it by 9 evenly. Oh, but I could divide it by 10 evenly. But 10, we already found 10. 10's on my other side. Which means I can stop there. And these are all of my factors for 50. So I'm going to swap colors. I'm going to swap to green. And now what I'm going to do is, once again, I'm going to circle all of my common factors. I have 1, obviously, because 1's going to be on every list no matter what. Oh, look at this. I have 2 on both lists. Oh, 3's not on both lists, but 5 is on both lists. 6 isn't on both lists, but 10 is on both lists. 15 isn't on both. 25 isn't on both. 30 isn't on both. And 50 isn't on both. So now, well, we look at these numbers and we think, well, which number is greatest? Which of these is the greatest number that they have in common? And that's going to be 10. 10 is going to be my greatest common factor. So that means that my answer to this is going to be 10. Okay. I think we've done enough work with greatest common factor. Let's scroll back up a little bit and look at what least common multiple is all about. Least common multiple is basically the exact opposite of what we've just did. Instead of breaking apart my 12 and my 18 into their factors, I'm going to expand my 12 and keep going with it. 12 and multiply it by 2, then by 3, then by 4. So the first thing that we are going to want to do is, well, we're going to look at this. Find the least common multiple of 12 and 18. And it puts it in its notation for us. LCM 12, 18. So what this is asking me to do is find the least common multiple of 12 and 18. So let's do it. It tells us the first thing to do, write the first 10 multiples of 12. Okay, so that's 10 times 1, 10 times 2, 10 times 3, 10 times 4, 10 times 5, 10 times 6, 10 times 7, 10 times 8, 10 times 9, and 10 times 10. Or a better way to think of this, just count by 12s. I think we could do that pretty easily. Counting by 12s, we start with 12, 24, 36, 48, 60. That's halfway there. We're halfway done. Give me 1 second. 72, 84, 96, 108, and last but not least, 120. So there we go. We've listed out the first 10 multiples of 12. All we had to do was literally count by 12s. 12 times 1, 12 times 2, 12 times 3, 12 times 4, and on and on and on, until we get to 12 times 10. Well, those are our multiples of 12, and if we wanted to, we could keep going. But it tells us to do the first 10, so we'll stop, and we'll go on and find the first 10 multiples of 18. Okay, so once again, exactly like what we did before, we are going to be counting by 18. So 18, 36, 54, 72, 90, that's halfway there, 108, 126, right? Yep, 126, 144, 162, and last but not least, 180. So those are our first 10 multiples of 18. We've just counted by 18s all the way up until we got to 18 times 10. Now, what it asks us to do is circle our multiples that appear on both lists. So very similar to what we did up here on finding our greatest common factor, how we circled what was in common on both of them, that's what we're going to do over here. We're going to circle. Well, 12 isn't on both, 24 isn't on both, 18 isn't on both. Oh, 36. That's on both. Keep looking, keep looking. No, no. Oh, 72. That's on both lists. $84, no. $96, no. Oh, $108, that's on both lists. $120, no, 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 no. If we kept going, I know that 12 times 12 is 144, so this would be on both lists, but it's not right now, just because we stopped at 10. But that is a common multiple. But we don't need to worry about that because we're worried about what our least common multiple is. Put a rectangle around the least of these common multiples. So we need to look at all of our common multiples and find out, well, which one's the smallest number? Well, 108's the biggest out of what we have here. Obviously, it would get bigger if we kept going. 72 isn't. 36, that's our smallest number. That's our least common multiple. So what I'm going to do is I'm going to draw a rectangle around this. And I now know that my least common multiple is going to be 36. Now, my question is, did we really need to write out 10 of these for both lists? No, of course we didn't. Obviously, this was just a first example. So we just wanted to write out both lists. But if I was writing this list of 18 and I got to 36 and I'm like, wait a minute, 36, that was on my previous list. Then that lets me know, wait a minute, that's my least common multiple. I've found one that's on both lists. The first number that you find that's on both lists, that's your least common multiple. So we could have stopped right here. It could have just been like, oh, 36 is on both lists. 36 is my least common multiple. We didn't, just for the example, but we could have. Let's do one more. We'll do least common multiple between 9 and 12. So, same as before. This time I'm going to start out with the number 9, and I'm just going to go through my 9s. So, 9, 18, 27, 36, 45. And you know what? I'm going to stop after 5. You know why I'm going to stop here? Because, well, we've already listed out our multiples of 12. So we should already know that we've already come across a multiple of 12 in there. But just to remind us, I'll do our multiples of 12. We have 12, 24, 36. Oh, would you look at that? We've come across a common multiple. This is the first multiple that we've come across that they have in common, which means that our least common multiple has to be 36. What I want us to do today, I know that there is more for us to do, such as this station 3 and then this station 4. We'll work on those tomorrow. But what I want us to do today, your assignment for classwork is Station 1, Parts A, B, C, D, and E. And then Station 2, Parts A, B, C, D, and E. Don't touch Station 3 yet. Don't touch anything that's under Station 4. We'll work on that stuff tomorrow. You are to work on A through E for both Station 1 and Station 2. That's your only work I have for you guys today. Of course, if anybody has any questions as you're working through it, just don't seem to understand something, don't worry. Send me a message on Schoology. Let me know, hey, I need some help. I don't know what I'm doing. I'll tell you to come into the Teams meeting. We'll work through it together because I know that you can do it. Okay? With that, I hope everybody has a great day, and I will see you guys actually again for our first day back in the Teams meeting officially after break tomorrow. Farewell.